Hi guys, hope you're all surviving this new year. I thought last year was crazy, this year's even worse. So yeah, good fun, good fun. I'm just here running an MTU 396 today. I'm going to dive a video, first one of the year. We have run some engines this year, but we just haven't got around to putting any videos up, which is a bit slack of us, but anyway, we're getting there now, getting back into order. So I've done a few of these 396s now. They're just still always something new comes up. So, but yeah, this one's going really well. Already done a full horsepower run. I'm just going to run it up again, do another full horsepower, and muck around a bit, which you'll see on the video. So, anyway, guys, I'll just swap her out and let's have a look at this thing. So here we are now, just running it up. Just slowly getting stuff back up to temperature again after having a bit of a break. A bit of smoke and that sort of stuff. These really are a Formula 1 motor. They're the same engines that they put in the Leopard 2 tanks in Germany, so they're a military spec motor. I've spoken about them on some of my other videos when we've run this up. Just all the Inconel components in the exhaust system and the extremely close tolerances that they run in the crankcase. Pretty much just give everything enough room to move and they suck everything back in again. So if you've had a look at our videos with our 3516s from this angle that I'm looking at now, you can see how much smaller this motor is for nearly equivalent horsepower. So it's yeah, it's quite impressive, quite an impressive bit of kit. So once again, the military sort of electronics in this thing, everything's at 24 volts. It's 24 volt for the sensors instead of running 5 or 8 volt. They run 24 in there. Extremely robust electronics. It's like a briefcase, the ECM, the size of the ECM. It's briefcase size and extremely robust bit of gear. But you can't take anything for granted on these engines. They'll certainly come and bite you if you try to take any shortcuts on it. So this engine's had a W6 rebuild. I'll try and send through some photos of the build procedure as we've been going along. But anyway, alright, sit back and enjoy the video, guys. Just before we get into the dyno run, I thought I'd just show you a few things on how we go about building these engines. They're quite unique in what they do as far as their assembly procedures and things like that. They're different to any other engine I've definitely worked on. So here is an example of the cylinder block after it's been machined. We've gone to a 0.2 oversized liner, so it's oversized going down the bore, and it's also 0.2 mm thicker in the chamfer. So this is the factory overhaul procedure that they do in order to bring it back to 0 hour unit. So as you can see, the little ridge in the top of the block there, that's where it's an 1/8 hour or 0.2 of a millimeter cut just so it can allow for the 0.2mm thicker chamfer. So that's back to now original OEM first oversized liner, so it's ready to do another 30,000 hours. So we're going to the next photo now. This photo is of the cylinder block with the main bearings in there, ready to put the crankshaft in. As you can see, the main bearing, they use studs for the main bearings. Those studs are replaced during the build. We tend to do a tension on this probably 4 to 5 times before we actually put the crankshaft in. So crack testing, measuring of tunnels. You can't do any machining on the block unless the tunnel's tight. You can see how small the cylinder block is for a 48 litre engine. It's amazing how small that block is. And without the main bearings being done up, you do get a distortion in the block. So with the main bearings done up, we need to do all the machining while that's getting taken place. So the caps are off, they're tightened. After the crankshaft comes out when it's disassembled, then we bolt the caps back down again, check the tunnels, take them back off, do the crack testing, bolt back down, do all the rest of the block machining. Then it comes off, back in with the new bearings once all the tunnels been done. Then we measure the bearing clearances, then off again, and then this procedure now with the crank going in. So the new studs go in just before the crankshaft goes in. If you have a look at that crankshaft, it's a billet crankshaft made out of solid block of steel, quite a work of art. Bolted counterweight bolts, new counterweight bolts go in. See the little pink stickers that I've got over the big end bearing journals where the oil comes out. The reason for that is that these crankshafts are very hollow. They're all hollowed out for weight saving and things like that. And they use a swaging, a plug that's swaged in there. So once those plugs are in, you can't clean the crankshaft. So the plugs come out, the crankshaft gets cleaned, plugs go back in again, swaged in with like a steam compressor tool, a boiler expanding tool that they use for boiler tubes. They expand it back into a tolerance. Once they're in, you can't clean the crank anymore, so that's when the stickers go on straight away on the main bearing, where the main bearing oil feed comes out of the crankshaft, and also the big ends. It's sent away then for balancing, so it gets balanced and then back it comes. And we don't take those stickers off until the last minute, the very last second before the crank goes in, to ensure that it stays clean. I use endoscopes and things like that when it comes back from the balancing to make sure that there's been no contamination put into the crankshaft while the balancing process has been taking place. But we eyewitness that when that gets done to make sure that no one's sort of taking any shortcuts on that sort of thing. So that's the crankshaft about to go into the cylinder block. The large crankshaft for a very small cylinder block. So as you can see at the end there, I'll mention it probably later, but the gear train is already in the engine as well. It doesn't have a front cover for the gear train. It's incorporated in the cylinder block. So first thing that goes in is the gear train before the crankshaft goes in. So just for something a little different to your normal build. And as you'll notice there also, there's no slipper bearings for thrust. The thrust bearing is done a little differently, which I'll explain later. So we go on to the next photo. Here's the crankshaft and the cylinder. The cylinders are together. The liners have been put in the block. Pistons are in with the rods. As you can see, the rods there on the end of the crankshaft on the journals. You can see on that photo, it's not the best example, but you can kind of see how close they run the crankshaft to the cylinder block. The clearance between the counterweights and the liners can be as little as 30 thou in some places. They put that crankshaft in and they compact the cylinder block around the crankshaft to make it a real tight fit. Worked on Caterpillars and Cummins, the American side of things. You can stick your hand in everywhere. You can't get in anywhere there. Not a lot of room at all. Very compact. Those rods are like a Corello rod. They're quite sexy to look at, actually. Their weight is similar to a canine end rod, but they're actually lighter than a canine end rod. We just did a bit of an experiment there a few years back and we measured them, and the weights are nearly half a kilo lighter than a canine teen rod. These are 4 litres a cylinder, so to give you an idea of how much lighter that rod is compared to an engine of smaller capacity, it's once again, it's just a credit to the Germans for doing what they've done there. Of course, it's expensive, but for the military and government type owners of these motors, they do the job very well, and they've got the weight on their side to horsepower. So these things come in dry around 3.9 tonnes, and they're upwards of 1700 horsepower and above. So to give you an idea of that, I know the B series low displacement 3516s are around 2000 or 1900 horsepower, and they're 8.5 tonne opposed to 3.9, and they're not water jacketed exhaust manifolds and things like that, which you'll see coming up. These have a very, very low thermal footprint as far as when they're in operation. You can pretty much touch any part of the engine and not get burnt, so they've got that going for them as well. So anyway, we'll get on to the next video. Here's looking at the back of the engine. Once the crankshaft sump's on, everything's in. You're looking now at the flywheel end, which, as you notice, has no bolts. So the flywheel is actually hydraulic onto the crankshaft, and contracts on once that hydraulic pressure is relieved. We're up to about 35,000 psi to put those flywheels on. Once they're on there, they ain't coming off, and they actually use the flywheel, which you'll see in the next photo. They actually use the flywheel to set the end float of the crankshaft. So the flywheel does bottom out up against the crank, but it actually sets the end float. So you've got a big ball bearing that sits in there, which we'll see in the next photo. It sets the end float. So you need a special tool to hold the crankshaft in position while you're doing the build. Otherwise, that crankshaft right now, as you can see it, if the tool isn't in there to hold the crankshaft in position, it can just float. It can float inside the main bearings and run up against the radius of the main bearings and do some damage. As you can see from the last photo, that there isn't a lot of room for it to move either, so you've got to be extra careful there that you don't do any bruising of the crankshaft or main bearings prior to putting the bearing in, the flywheel housing on, then the flywheel on, and then you can remove the tool after that, after you've done your checks. So you'll see that in the next photo. And that's with the flywheel housing on now, and we have the bearing in. You can see the holder of the balls there. That's the gold coloured cage that's holding the ball bearing. There's the notch at the top there, which the flywheel spigots into. The little notch on the seal carrier, which spigots into that. The retainer plate's on, so that flywheel is ready to go on now once I put the rear seal carrier in. The rear seal carrier isn't in yet, so it's all O-ringed up and comes back from there. I'll go on a bit later on about the paint work that we do. That's been painted there in a particular type of paint. We mark all our bolts before they're done, so we can be sure. I normally take some photos at critical points just to show evidence that that's been done, and we've gone about the procedures. So that's that one. So we'll move on to the next photo. Here's the cylinder heads going on. Cylinder heads getting tensioned up. They run a type of clamp system there. They run two different size bolts in diameters. The middle ones can't remember offhand now, but they're quite a bit bigger than the ones on the outside. They're not overly tight in comparison to the American counterparts when it comes to tensions. They're an angled tension. I'll use a digital tension wrench there, which always remains in calibration. Pretty critical on that. Not an AQA, but we have the tension is roughly around 300 foot-pound when they're about finished, between 200 and 300 from memory. I can use that with a digital tension wrench to see after the angled tension what they ended up at. But compared to American stuff, the Americans really grunt down on those heads. So this has around about the same amount of heads, but their individual head design, which I've never been an overly big fan of, can cause fretting and things like that. I much prefer one big cylinder head, but that's the design they've got, and it still works well. So they use the part of the main bolts there. You can see they run a bracket off for your fuel return rail and things like that. So they incorporate a lot of things to keep them compact once again. So they're actually a brand new set of cylinder heads. I think those 10 new ones went onto that. So the others were out of service as far as their specifications go. So new core heads there. Here's some of the parts prior to them going onto the engine. We individually paint these engine parts. in International Interthane paint, which is a really good quality paint. I really like it. It goes on really well. Extremely robust paint. Doesn't discolour with heat, and it's got very good properties against catching fire and things like that. It's again, we have intercooler before the intercooler you can have intake temperatures up plus 200 degrees, and we don't get any discoloration in this paint. It's really good. So use a 2-pack primer and send it out to a booth and get it baked on. So they come up really nice in the end. They look really good and really clean, and we can assess. And one thing I find it tends to do as well is it makes you a lot more cautious when you're assembling the engine. So it's one thing to sort of assemble the engine with no paint and clean parts. It's another thing to assemble it when parts are pre-painted. So everything is really delicate when it's assembled, which I find is sort of an extra protection against being a little bit heavy-handed, I suppose, with things. So everything when it goes on is it sort of flows onto the engine rather than sometimes kind of being a little bit less, having a little less finesse when it comes to not being painted. But I mean, we're always very careful, but it is one level again when the paint's on there. You just, obviously when it goes on, you're lifting it on nicely and making sure nothing gets scratched. So it does give that extra precautions on the build, which I actually quite enjoy pre-assembling. It's a lot of extra work, but I actually enjoy assembling them when they're painted. It gives you a lot more sort of, like I said, a lot more care, but it's also, it does look a lot better, but it's a lot more work because you can see wherever the bolt bottoms out, wherever a bolt goes, you can't have paint underneath the bolt. So everything has to be individually taped, or you need to have the stickers on there to make sure that there's no paint underneath. Because one thing that will happen when that engine does heat up, if you have paint underneath the bolt, it will loosen the tension. It does loosen the tension on the bolt over time as the paint softens. So very important that every single surface that has a bolt on it has to have no paint underneath it. So it just makes it that extra amount of time to do it, but it is quite rewarding during the build to see it go together pre-painted. It is really good, and you don't have any overspray at the end of the job too, so it makes the engine last a lot, well, the appearance lasts a lot longer. Any dust or dirt can be wiped off rather than getting stuck into any type of overspray, which is unavoidable if you don't pre-paint your parts. So quite time consuming, but very rewarding at the same time. So here's a photo of the exhaust system. I haven't seen an engine that has an exhaust system quite like this. Uses Inconel. There's an Inconel shroud you can see on the inside. You can see the O-rings there where the water jacket is, where the water manifold, the aluminium housing goes over the top of that Inconel deflectors. Right even through that joiner piece there, it's water jacketed. So they use these engines, I think I mentioned earlier, in military applications, in tanks and things like that, where I think a low thermal footprint is extremely important. So not only is the engine light, but it has this incredibly low thermal footprint as far as exhaust temps and things like that go. You don't have any exhaust. That gets upwards of mid 600s at full horsepower, and you can touch any part of the engine. Even the turbo itself is encapsulated in a water jacketed housing, so the outlet of the turbo has an elbow, Inconel elbow, that comes up to a flat piece, and then after that it's hot exhaust. But every part of the exhaust system is encapsulated in a cooling jacket of some description. So that's that Inconel alloy. That's a nickel chromium super alloy, I think they call it. They use that stuff for turbine blades in planes and things like that. So very thermally, what would it be? Very thermally resilient alloy. It doesn't have a great expansion rate when it gets hot. And those bolts, you can see that are bolting all that together, are also an Inconel bolt. So quite an expensive little piece of merchandise there. Even those bolts, they only go up to a very low tension because of the thermal expansion being quite low in the metal. They don't tend to need high tensions, and nor do they request high tensions to tension tension those two halves together. So just another thing that's a little different to other engines. Quite incredible how they've designed that, and yeah, hats off to them. And it's good fun putting it together, I must admit. They don't use any gaskets between those surfaces. They just use a particular sealant that goes in there to put all that back together again. And yeah, so that's just something a little different on the build that we don't sort of get on normal engine builds. So there you go. Just a little shot of the start of the front of the motor there. We've got the main thermostat you're looking at, the main thermostat outlet there at around a 70 odd degree thermostat. It's been remanufactured. We remanufactured it in-house. It's got a thermostat also for the intercooler system, which regulates the cooling water for the intercooler at around 42 to 43 degrees. So two different circuits for the engine. There's also the water pump. That's the one on the right. You can see lower there. That's the low temperature water pump for the intercooler, and then the high temperature one is behind on the left hand side there, which you can't see in this photo. So that's just a frontal shot of the engine. We got the green thing there, which is the supply pump for the main fuel pump, which puts out about 30 psi, 30 to 50 psi. The secondary fuel filters are up there on the right hand side. So there's a real procedure to putting this engine together. If you go to put something on and you haven't done something behind it, you're going to pay. You're going to either need to take it back off again, or yeah, you pretty much have to take it back off again. And as mentioned before with the paintwork, one of the advantages and disadvantages, I suppose, is that you've got a lot of finesse when you put it together, and if something's not put on before the next thing goes on, well then yeah, it's got to come back off again. Otherwise you're going to risk any scratching or denting or something like that of the componentry. So always very careful putting it together and very methodical. Here's the final photo I've got to show you. It's getting close to the finishing product. I haven't got the bleed lines on the top of the engine yet, but that's pretty well 99% built there. So we got to go ready for dyno. We inspect the electrical system, the electrical box there on the side. That's not the ECM. The ECM's separate to that, so that's just like a box that contains all the wiring to go out, to pin out to the ECM, which is traditionally in the machine. They don't bolt them to the engine like they do in some of the American equipment. It's pretty antiquated electronics. I really like it. Extremely robust electronics. I think I mentioned it before. You saw the video on the run, but extremely robust. Uses 24 volt for all the sensors and things like that. So milliamp outputs. There's 3 wire outputs on most ascenders. So typical to what they use today, but just so much more heavy duty and sort of built to last. So yeah, quite impressive there. And I don't think there's much else to show you in that photo. You can see up in the corner there the water jacketed turbo. So the whole exhaust side of that turbo is encapsulated in that housing, and you can just sort of see the exhaust outlet coming out the top there. So there's an elbow, right angle elbow, that comes out all Inconel and comes out to that face, and then the exhaust goes from there. So the whole turbine housing is encapsulated in a water jacket as well for that thermal efficiency. So I don't think there's much else in that photo that's sort of interest, but yeah, very good looking motor. I think that the Germans have done alright. The engine mounts are nearly as big as the engine, as you can see. I think they may do that because the block's so light. They don't want to stress the block, so you always got to be floating it on rubber. If you try to, I suppose, chop faster down in a boat, marine, without mounts, you'd probably risk distorting the cylinder block. It's that light, because what you're looking at mostly there is the sump, as being the bottom half. It's a huge aluminium sump on there. The block is, well, you can't even see that cylinder block in that photo. That's how small the block is, which you could have seen on earlier photos. So anyway, I hope you enjoyed the little narration. I'll get on to the dyno run. We'll keep it pretty short because we're already 24 into this video, so I'll just show you some of the maximum horsepowers and things like that. One of the interesting thing this has is a sequential turbo, so you'll see in here the flap open They run on A-bank up until 1500 horsepower. You've got to get to over 50,000 RPM on A-bank. They monitor the turbo speeds and the ECM reacts to that. So we've got to be at 52,500 or something from memory. I'd have to look at my sheet there. But before the B-bank will come in, so you'll hear the B-bank flap open. So that's something that they are doing to run boost pressures at certain RPMs to keep that right. So A turbo is a lot bigger than B turbo. Most of the time you're running on A-bank. Starts off on 2 turbos, goes to the 1 turbo, about 400 horsepower thereabouts, and then it'll go back into 2 again at the higher horsepower. And it's always a little bit frightening when you hear it for the first time, that B open up, because gee, she spills up real quick after that. So you'll see that in that video coming up. Yeah, so I hope you enjoyed it. Any questions you can put in on down there in the comments and that. I'm a bit slack with those sorts of things. We're not YouTubers by heart. I'm not going to edit this video or the speech or anything like that. So hopefully didn't hum and har it through too much. And yeah, enjoy the dyno run, and hope you're doing okay in these crazy times. All right, guys, talk to you later.